This morning to talk about the coal mining legacy in South Wales and how we deal with it. I'm going to put a bit of geology and a bit of history in together. So see if I can get this to work. There we go.
I hope it.
All right. So I'm going to talk to you today, brief introduction to coal, where the UK coalfields are, how the coal was won, what is the legacy of the past mine workings across the UK, and particularly in South Wales, obviously. How do I identify and assess the risks, and then how do we mitigate the risks? So the basic question, what is coal? I'm sure most of you know, but there is a member of our esteemed government who this week demonstrated that he doesn't really understand what coal is. It's a sedimentary rock formed by compression, lithification, organic materials, and this is the bit which that gentleman didn't seem to understand over millions of years. UK and American coal is obviously from the Carboniferous period, which I'm sure many of you know, but it's not like that across the whole of the world. In Australia, for example, the coal is Permian. The coal was laid down, the plants rotted, and then covered by sand, mud, silts. So you have a sequence, interbedded sequence of mudstones, siltstones, sandstones, the coal seams, and also seat earths. Now, seat earths were underneath the coal seams, and they're effectively with the topsoil that those plants grew in. But those were lithified as well. You still see those in the succession. A whole sequence of those. So you have a series of what known as cyclothems, one above the other in this succession. I was at a webinar earlier this month, or last month, and the guy giving it said, oh, if it's coal's coal. That's not true. There are four main ranks of coal. Lignite, which is soft brown, combustible, sedimentary rock. It really isn't just one step up from peat, really. It's the lowest rank, lowest heat content. We don't deal with it much in the UK, but places like Germany, there are quite a lot of lignite seams. Subbituminous is the next one up, increased carbon content, higher heat content. Next one again is bituminous. That's further increased carbon content. It's got a high volatile content, which makes it less good to burn than the top ranks, but it is the most abundant rank of coal. So most coal seams across South Wales and the coalfields would be bituminous coal. Top rank is anthracite. That's the highest carbon content. That's the stuff the coal man used to deliver in the 60s, 70s, and possibly 80s. It's got the highest energy density, it's got the highest ranking, and it is the most sought after and profitable. Now, this matters because when you're looking at a coal seam, if you know whether it's bituminous coal or anthracite, if it's anthracite, it's far more likely to be worked. UK coalfields, I'm sure quite a few of you know about these as well. Got the Scottish coalfield up in the Midland and Central Valleys of Scotland. Then got the Northeastern coalfield, the Cumbrian coalfield, Yorkshire coalfield, Lancashire coalfield, Staffordshire coalfield just north of Birmingham. It's a coalfield in Kent, not many people know about, which is underneath the chalk. Got the Bristol coalfield, Forest of Dean coalfield, and obviously the one I'm going to concentrate mainly on, which is the South Wales coalfield over here. So the South Wales coalfield, for the geologically minded, it's an elongate syncline. For the non-geologically minded, it's a bowl. So basically what we have along the northern margins, so we've got sort of for Ammanford over here, Merthyr in the middle here, and up towards Blaenavon, and then along the southern margins, sort of Briscoe area, Bridgend, Swansea, and along the eastern margins, which is around Pontypool, Cumbrani area, and over in Kidwelly over in the west. The deposits are thinner. The coal measures are not very thick at all. But in the central area, you've got quite a substantial thickness of what I know as the coal measures with the coal seams in it. It's the Pembrokeshire coalfield over here. It's actually the same coalfield, but Carmarthen Bay has taken a big chunk out of it here. Okay. The coalfield isn't straightforward, though, because it's disturbed quite heavily in places with geological faults, particularly. And you can just about see one of the big ones coming through here, and that's the Neath disturbance, a major fault. Just an indication of the number of collieries there were in South Wales in 1893. the larger the circle, the bigger the colliery number of workers that work there. So I forgot to put my clock on. Sorry, excuse me a second. Okay. Main thing to look at that was the 1893 situation. That's nowhere near the number of collieries there are across South Wales. But what it does show, again, is you can roughly see that there are these collieries run in lines following the river valleys. Okay, now I don't know how well you can see that. Is that clear? What I've done there, that's a section through the various parts of the coalfield. So over in the west, the Pembrokeshire coalfield, you can see, if you remember, I said there were thinner deposits over there, as you can see there are here, and ditto over in Ebbw Vale. But in the central area, this is Llanelli, and this is Pontypridd. This is the sequence of strata basically in these areas. So what we have is the lower area is known as the lower coal measures, the lower deposits. Then have the middle coal measures in the middle, and then the top would be the upper coal measures. Okay, and you can see there's quite a regional variation across the coalfield. The lowest point of the defined lowest point of the coal measures is the subcrenated marine band, which is right down at the bottom here. And the top is the pennant sandstones, which occur at the top. Okay. So you might think, well, why is there a difference here? Well, basically, the coal wasn't laid down in the Pembrokeshire coalfield, or if it was, it's gone. It's been eroded away over the millions of years since. You can see also that the seams go between the various areas. And I've highlighted a couple for you, just to give you an example. You've got number 2 Rhondda over in Ebbw Vale, which is quite a major seam, quite heavily worked. It's also known as number 2 Rhondda in the Pontypridd area, which is great. But once you get to Llanelli, exactly the same theme. It's not called number 2 anymore. It's called the Wernthi. So the seam names change. The 9 feet seam over in Ebbw Vale, again, it's the 9 feet seam over in Pontypridd. It's called the big seam once you get to Llanelli. But then once you get to Pembrokeshire, it's the timber vein. So it changes. Now, those are regional changes in names, but it's not quite as simple as that even. Because when you get locally, the same seam can have dozens of different names. Got an example here. It's the Swansea 4-foot seam. Again, heavily worked seam in the Swansea-Llanelli area. In Swansea, you might find records which have Fernraith, Church Vein, Primrose, Broad Oak. They could be records of those seams. They're all the number 4, the Swansea 4-feet seam. But when you get to the Llanelli area, I'm not going through all those names, but you can see there is a huge note. That's the same seam. Different records of that workings in that seam will have those different names. 2 I want to point out as well is the Rosy and the Fiery. Now, those are 2 very well-known seams in the Llanelli area. The Swansea number 4 feet is called those in different areas, but also the Rosy and the Fiery are different names for other seams as well. So if you end up with records of the Fiery seam, you've got to know whether you're talking about the Swansea 4-foot seam or whether you're talking about another seam altogether. It's a minefield, literally. Just a quick slide on, just giving an indication of the history of mining. This is UK coal production. The red line is UK coal production. So you can see early 1700s, it climbs very slowly to about 1800, and then from 1800 through to 1900, there's quite a large increase in mines. This is the scale in million tons of coal produced per year. So the peak production was around 1900, 1910, where you're talking about 30 million tons a year. And this is across the whole of the UK as well, so not just South Wales. After that peak, it dropped away a bit, partly due to World War I. Increased again between the wars, dropped away again during the Second World War. And as you're probably well aware, since the Second World War, the coal industry has been in steady decline until there's nothing left of it really now, very much. What I've also done is I've highlighted some interesting acts of parliament that I thought you'd be interested in. So we'll just go through some of those. In the 19th century and 18th century and early 19th century, collieries were an incredibly dangerous and hazardous place to work, as you're probably well aware. It was so bad that in 1840 there was a royal commission by the government, ordered a royal commission, and that came up with a huge number of recommendations and to make improvements. The first one was the Mines and Quarries Act of 1842, which prohibited women, girls, and boys under 10 working underground. Before that time, boys were extremely valued because they were small and they were able to get to seams and workings which were very, very narrow, very low height, so they could get to places adults couldn't get to. They were very valued, not for their lives, but for what they could do. The other thing that came in with 1842 was for the first time collieries and mine workings were tested for mine gas, which can be hazardous, and I'll come on to talk about that a bit later. In 1860, 1872, two Coal Mines Regulations Act, both improved safety rules. 1860 raised the age of boys working underground from 10 to 12. 1872, pit managers were required to be trained and qualified. Believe it or not, before that, they didn't have to have any qualifications or any training at all, hence the number of accidents probably. The other important thing about the 1872 Act, for the first time, the mine owners had to survey their underground workings and lodge those survey plans with the Secretary of State. The plans that were produced when the colliery finished, so it was the maximum extent of the workings, were known as abandonment plans, and they're actually quite important. We'll come on to those in a bit later. 1881, for the first time ever, the Home Secretary had the power to hold inquiries into accidents in collieries. Unbelievable. It took till then. 1887, another Coal Mines Regulations Act. For the first time, there had to be two mine entries, because before that, if there was one shaft, that was absolutely fine. The problem was, if there was a problem at that shaft, if it collapsed or whatever, the collies were stuck underground with no hope of escape. Very similar situation to the situation in Chile a few years ago, if you remember. So from 1887, there had to be two mine entries. So if there was a problem with one of them, there was an escape route. 1911, working hours limited to 8 hours. 1950, for the first time, I believe for the first time, if you had subsidence on your property due to coal mining, you were allowed to claim for compensation. 1954, Mine and Quarries Act. This was a big one. This improved huge number of things with in underground workings: ventilation, welfare, egress and ingress routes, just huge number of different things to improve conditions and safety. And the 1994 Coal Industry Act, well, it didn't actually do a lot for coal mining because there wasn't any left by then, really, not much. But what it did do was it created what's known as the Coal Authority, which I'll talk about a bit later. And the Coal Authority are responsible for coal assets in the UK. So, for example, if you decide you want to go and mine some coal somewhere, you will get a permit from them, and you will also give them whatever per tonne as a pay them whatever it is as part of the. What am I trying to say here? You know what I mean. Anyway, sorry. The other thing with the Coal Authority is that because they own all the assets, if we want to drill boreholes to look for coal seams or whatever, we have to get their permission to be able to do that. Again, I'll come on to that a bit later. So far we've talked about coal, but as Kevin Privet said to me a couple of weeks ago, this isn't a lecture on coal. This is a lecture on the space that's left where there used to be coal. So how was the coal won? Early mining, well, there's records that show that there's coal's been in the UK has been worked since at least Roman times, and they used coal heating along Hadrian's Wall in the Roman times. But coal was also burnt on funeral pyres in Wales during the Bronze Age. So the likelihood is that coal was basically won from surface exposures where the coal seam came to the surface in upland areas. No venturing underground to get it, just at the surface. It would have been in the upland areas because in the valleys, all the soil that's covered the bedrock would have basically meant that they would not have known where the coal seam were, and they couldn't have got it anyway. They couldn't have got down through the soils. So the first venturing underground was via drift mining, which effectively are just tunnels in elevated ground. In the early days, they were only driven short distances and were on limited extent. Mainly, due to the fact that they didn't have the ability to support the roof of the workings. So when you get in here, it's very important you keep the roof up and it doesn't collapse. You can still see crop workings across South Wales, outcrops and on the high ground, and I'll show you an image in a minute of those. Very common mine workings entries in the 17th and 18th centuries. And as time went on, some of the individual drifts began to connect together underground. This is a LiDAR image of hillside of South Wales, and you can see where I circled, you can see these areas. These are all drift mines and crop workings. And looking at it, there's also some more over here. These are still evident. I was doing a job last month near Pontedales, and there's drift workings up on the hillside immediately above the site. Follows the coal seam. So the likelihood is the coal seam runs straight through here. Okay. After drift mines had got going, the next method of getting underground was something called a bell pit. Now, bell pits, as you can see, effectively are a narrow shaft, maybe 1 to 1.5 meters diameter, going down to the coal seam. When they got to the coal seam, they then widened out in the workings, and hence the sort of bell shape, but hence the name. Generally, they occurred where the rock was, the coal was relatively shallow, and then generally not very common at depths of more than 10 to 15 meters. And they formed along the line of the coal seam. As time, the limitations on the side of this bell pit, size of the bell pit underground here, was basically, again, as I said earlier, is the roof support and being able to support the roof. In the early days, they probably wouldn't have been able to go very far at all. But then using wooden pit props and things like that, they used to be able to then move a little bit further. And as they moved further, as these chambers got wider, the separation of the shafts, so the bell pits, increased. Okay. This is an image, a drone image of a site, I think it's in Leicestershire, and that is not a Connect 4, buried Connect 4 board. That is a whole series of bell pits, the entrances. You can see over on the left-hand side, the shaft entrance. On here's the pit props just supporting the roof down here. Now, this is an image I got from a webinar that I attended, so I don't know much about this site at all. But looking at the close proximity of these bell pit shafts, I would say this is a very early set of bell pits because the chambers aren't very wide. And again, just an image showing sections through some bell pits in a cutting. So this is the actual chamber here, and the shaft would have gone up there. Another one here. And obviously all been filled in by the soil over the years. Bell pits then developed into, as they extended and went further away, they then, and roof support technology improved. It developed into pillar and stall mining. It's also known as pillar and room, board and pillar, room and pillar. There's half a dozen other names for different parts of the coalfields across the UK. They've got different names. South Wales, it's generally pillar and stall. And the way these operated was they left pillars of coal from the seam in situ to support the roof. Okay, so they moved and mined out in between these. So you ended up with this sort of net type pattern. Initially, they didn't go much more than 40 odd meters from the original bell pit entrance. But then as time went on, they were able to get further, technologies improved. And by the 17th century, they extended maybe up to 200 meters from the original entry. And they were even up to 60 meters depth, some of them. As an example, some photographs of some pillar and stall. So you can see the pillars here, which were left in situ, and they took the coal out from in the middle here. Now, the width of these voids between the pillars depended very much on the strength of the coal in the pillar. Was it able to support the roof? So if it was a friable coal, it wouldn't be able to support, it would collapse. So you'd have narrower rooms between the pillars, but also the roof rock. So if you had a massive sandstone immediately above the coal seam, that would act as a concrete slab and would span quite a large distance. So there you might have stalls 4 to 5 meters wide. Generally, in my experience, they tend to be 2 meters, 3 meters at most. Now, pillar and stall workings, these are the most of the mine working legacy that we end up dealing with nowadays is pillar and stall. Okay. Now, in early mining, when they were taking the coal out, they also had to take some of the roof rock out. They may have taken some of the floor out just to be able to get in and around. So they produced a bit of waste rock. Now, in the early days, that was basically just stuffed into old workings they weren't using anymore. What we call stowed. And quite often if we're drilling now, we'll find backfilled working. Well, not backfilled, they're just wasted, if you stuck into it. But as the coal production increased, the waste rock started to get taken to the surface and then tipped on land above the surface. Hence the reason we have so many coal tips in South Wales. As you can see from the photographs, pit props still used to support the workings. You've probably heard the term that Nelson's Navy was built from oaks from the Rhondda there. I don't know if you're familiar with that term. Well, I'm not sure I agree with that. I think most of the oaks in the Rhondda went underground as pit props. And on the right, these are photos on the right from a site in Swansea. That's the actual workings. So you've got pillars. They're totally degraded, as you can see, but that gives you an idea of what it's like. We drilled into them and stuck a video camera down there and got some pictures, which are quite interesting. And those are the voids we have to deal with now because of the workings. Now, when the colliery came to its end of life, whatever reason that was, whether they'd run out of room, they got to groundwater and they couldn't go any further, whatever it was. What they used to do was when coming out, they didn't care about the roof staying up anymore. So what they used to do is, as they came back out, they robbed the pillars of coal. They made the pillars narrower because they didn't care if it collapsed behind them. And typically in Llanelli, as an example, as they went in to the workings through the coal seam, they would take out about 30% of the coal and 70% of the coal would be left as pillars to support the roof. But when they came back out again, they would take another 30% from those pillars. So you end up with 60% voiding in the Llanelli area in some places. I said about groundwater a minute ago. South Wales groundwater was a major problem, and in the early days, they just didn't have the pump technology to be able to get rid of it. But as workings went on, 1960s, 1970s, the groundwater was lowered quite substantially across South Wales. And of course, in 85, 86, when most of the collieries shut down, the pumps were turned off and that groundwater is continuing to rise. It may have stopped by now, but throughout most of my working career, rising groundwater has been an issue. So post World War II, pretty much all mining was longwall. This is, if you talk to any colliers, this is what they got involved with. And the way this worked was they would have a couple of passageways. Sorry, I don't know why I'm pointing at the screen. I'm sorry. Couple of passageways, one either side. And then you would have a machine like this, cutting machine like this, which would go backwards and forwards, continuously backwards and forwards, cutting the coal, dropping it onto the conveyor belt here, which would then take to a side conveyor, and then the side conveyor would then take it to the shafts to get it back to the surface. These hydraulic rams here, they would support the roof in the immediate area of working, but these were tied into this. So as this moved forwards, these rams would follow it, and so all the roof above it would just collapse. They didn't care. That was total collapse. And what that ended up with was on the surface, you end up with a subsidence trough, which followed the workings. And the Coal Authority, well, British, what it had been then, British Coal, NCB, whatever it was, they knew about this. And so they could predict exactly where subsidence was going to happen in the 70s, 60s and 70s. And the final way of getting the coal is, of course, open cast, which is just basically a large quarry. This is up Merthyr Tydfil way. What this was particularly used for was when you had lots of thin seams of coal. That were valuable, maybe anthracite, but they weren't very thick, so they were difficult to work underground. But through open cast, it was quite easy. Just dig a hole, sort the coal out, and there we go. So mine entries, we talked about drifts earlier. They're also known as adits, levels, slants. And as I say, there were tunnels driven into the hillside to follow actually either following the coal seam or driven down through barren measures, as we call them, sandstones, mudstones, siltstones, down to the coal seam. Any coal mining that's happening in South Wales now, it's all drift mining. The Gleisian Colliery, which you've probably remembered from about 10 years ago and the disaster there, that was a drift mine. The other thing drifts were used for was they used to drive drifts from the lowest point in the valley up into the workings, and they would act as a drainage level. So any water that was in the workings would just come draining down and straight into the river, bringing all that lovely acid mine drainage with it. Mine entry shafts, mine shafts. Just three examples of shafts here. We've got the one in the middle is a masonry lined shaft. It's a more modern one which looks like it's steel or timber lined. And the one on the left is one we discovered in Barnsley in Yorkshire back in November. And you can see here's the mudstone. A gentleman dressed up in full breathing apparatus and dropped down into it and was able to take some videos. So we've got the mudstone here, bedrock here, and then the soil above it is supported to stop the soil falling into the shaft. They used to line the shafts. In this instance, it was with brick. Shafts often started out just as widened bell pit entries. And as I said earlier, often it was just a single shaft. And then my Acts of Parliament then required two shafts to be used. The benefit of shafts is you could drop one shaft and you could access a number of different seams, coal seams at different depths. And they would be known as different levels or landings, sorry. As you approached each seam, there would be an entrance into the seam, into the workings. Now, when you had two shafts, they're often known as downcast and upcast. That's nothing to do with getting in and out. That's all to do with ventilation. We talked about mine gas earlier. Again, I'll talk about it a bit later, but mine gas is quite hazardous. So you need to get it out of the workings. So you need good ventilation. And the way they used to do that was one of the mine entries, either at the top or, unbelievably to my mind, at the bottom, they used to light a fire. And if you know your physics and chemistry, if you light a fire, it produces a low pressure. The low pressure would then draw air through, and then that would then escape through the upcast shaft. So the air would be drawn in from the atmosphere through the downcast shaft, through the workings to a low pressure, and then out through the upcast shaft. There are over 170,000 recorded shafts across the UK, but it's reckoned there could be at least that number, again, unrecorded. And in terms of shaft depths and diameters, so you can see in the graph on the left is the diameter of the shaft, and on the right is the depth of the shaft. In the early 1600s, they were not more than about 1 metre wide and rarely went more than about 30, 40 metres. But then as technologies improved, diameter increased, depth increased. So, by 1900, you're talking about going to a kilometre. By 1980, there were some places in Britain that were going to over 1 kilometre depth, and up to 8 metres diameter. The deepest shaft in South Wales is actually at Nantgarw, up near Pontypridd, and that's 550 metres deep. Okay, so what's the legacy of past mine workings? If you want to get planning permission in a coal mining area, you have to get you put your application into the local planning authority, and they will go to a number of statutory consultees, one of whom are the coal authority, who I talked about to you earlier. And they will respond, say, yeah, okay, fine, we're not interested, or you might get a letter similar to this. This is a site in Bridgend. I've obviously made it anonymous, but it's a site we worked on. And you can see here the coal authority have expressed fundamental concern. That means they want you to do extra work. Why do you have to do extra? Why do you have to satisfy them? The Coal Authority are not only responsible for the coal, but they're also responsible for the workings. And if you have a subsidence issue at your property and it's due to the coal mining, they will pay you compensation. If you can get them to agree that it is mining related. So what they don't want is any future development to be liable to subsidence. So they will, before they will agree to you getting planning permission, they will, as a minimum in this instance, they would require you to do a phase 1 assessment, which I'll come on to, and possibly even investigation, and possibly even remediation and stabilisation. Talks about mining subsidence. This is a property near Pontypridd we worked on. You can see the cracking in the wall. That is, I haven't got a photo of inside, but inside there was a concrete floor. Well, I said there was a concrete floor slab. There used to be a concrete floor slab. It had to be taken up because it was so badly mangled because of subsidence. We got involved, looked at it and said, I thought, yeah, this is a mine shaft's caused this. There's a buried mine shaft underneath that wall there. Coal Authority said, no, there isn't. No, there isn't. So we did some investigation and we proved there was, and they actually paid out in the end and paid out for the repair of that building. Talked about mine gas. Some seams generate large quantities of hazardous gas. Not all. Some of them have. And obviously, if you've got workings, lovely place for that gas to collect. Now, the miners used to know them as fire damp, which we now know as methane, which is flammable and explosive, or black damp, which is carbon dioxide, which is toxic, and you can suffocate in it. You're well aware of Humphrey Davy's safety lamp of 1815, I'm sure, which then developed onto the traditional miner's lamp, which was a safe instrument to use. There have been several colliery explosions across South Wales, and the worst was Sengennydd in October of 1913. Sengennydd near Caerphilly. 440 people were killed due to a gas explosion. That's actually the worst mining disaster in the UK. They're not working, they're not underground working anymore, but the workings are still there, the gas is still there, and that gas can still cause a risk, which we have to think about. So how do we assess all these risks? First thing we do is a desk study. And it's exactly as we said, it sounds like you sit at your desk and you study various pieces of information. Go through some of these quickly. This is the Coal Authority website. This is a free resource. Anybody can look at it. And if you have a house, if you're looking to do anything in an area which is within a coal mining reporting area, have a look at this. It's really, really useful. You can see on here, you've got the purple lines, which are the coal seams. You've got blue shading, for example, here. That's areas where there is recorded shallow mine workings. The crosses are all mine entries, shafts and adits. And these areas you can see here, there's a black hatched area. That is what the Coal Authority call development high risk area. That's where they've got particular concern. So if you have a property that you're doing something with in that area, you're going to need help. Historical maps. I don't know how many have seen these. The Ordnance Survey have been mapping the UK since the 1870s. And these are brilliant, unbelievably accurate in my experience. I've highlighted some air shafts here, some mine shafts here that you can see. I know pretty much that there is a mine shaft there, and it is pretty much exactly there. If I can work out where that field boundary is and that field boundary is, I've got a pretty good chance I'm going to find that shaft because it's going to be roughly where it's shown. Not very helpful for underground workings, apart from in general terms, like if you've got a mine shaft here, you know there's workings underground somewhere there. They're not expensive. You do have to buy them if you get the full set, but there's lots of places now you can get them within 10 minutes online. But some are actually free online as well. Geological maps, and I'm not sure how many people are familiar with these. I'm sure you're familiar with the concept. This is an extract from the 1 to 10,000 scale geological map from the Swansea area. For those who know it, Mumbles is down here, and you've got Alpha School and Gower Road along there. The black dashed lines, those are where the coal seams crop out, and they're all named. And also it shows mine entries. As for example, there's a drift which goes into the hillside there. But it also shows really useful additional information if you know how to read them. And I'll use this as an example, for example. The lines, the parallel lines, dashed lines that follow up here go up into the hillside. And I don't know if you know this area, you'll know that this is the Clyne Valley. As you go up towards Gower Road, that's on elevated ground. That's a steep hillside there, and then it keeps on climbing as you go further north. So these seams here have been worked. So there's mine workings up here. This is, if you remember, I talked about it earlier, a drainage level. So that is taking water from the workings up here and dropping it down into the Clyne Valley and discharging it into the River Clyne. That's a really useful, interesting feature because, again, I don't know how many of you know Gower Road, but there's some very nice houses along the side of Gower Road in the Calais area. There's a plot absolutely bang there for, I don't know, about 20 years, was never developed. Why on earth are they building on this plot? And the reason they weren't building on it is because this drainage level ran straight underneath it, and nobody could convince the coal authority that they could build safely without that drainage level collapsing and blocking the drainage level. If it had blocked the drainage level, all these workings up here would have flooded, and all that water would have come flooding out in the area of Dunvan up here, Hendravoyle and that sort of area. So they basically prohibited development on it. They just wouldn't give planning permission for it. Somebody has developed it now. So obviously they have, whatever they've done, they have convinced the coal authority that they can do that. These 1 to 10,000 sheets are also available online as well. And sorry, over on the right-hand side is the stratigraphical section. So this is a section through the geology in this area. You can see the coal seams, the black coal seams, the Hughes seam, Pensland coal seam there, etc. It generally gives a thickness, but this is also to scale. So effectively, if you stick it, the one use of an inch ruler that I know of nowadays, because these are always 1 inch too. If you stick your ruler between that seam and that seam, how many inches, multiply by 500 feet, they do calculation, you work out how many meters that seam. So if you know you've got the Hughes seam cropping out on your site at surface, you can calculate exactly how deep you'd expect the Penland seam to be under the ground. Brilliant books, these. These are the Regional Geological Society regional memoirs. And believe it or not, the old memoirs, the Ammanford one there you can see on the left is probably about 1916. The Pontypridd one is 1960. These older memoirs, far better than the new modern memoirs in terms of the detail they have on coal mining. Not necessarily for the general geology, but for the detail on mining. The sort of detail include here, this is a shaft section through the Llanharan Colliery. So you can see at the surface, again, that's reasonably clear, hopefully you can read it. It shows you've got 11 foot 6 inches of drift, that's soil, superficial soils. You then got the bedrock at 11 foot 6. And then it's got the various coal seams going down and the various strata between them. So 2 feet 9, for example, is at 211 feet 6 inches, and it's 10 foot 4 inches thick. British Geological Survey website has records of lots and lots and lots, hundreds of boreholes across the UK, and they're colour coded. So, for example, the blue, I think, is less than 5 meters. Green, I think, is between 5 and 10 meters. And the red is greater than 10 meters. So I've highlighted this one here, for example. This is obviously, it's near Caerphilly. It's the Ruday pit. It's 80 meters depth. And if you were to click on that online, it would give you the borehole record, the shaft record for it, which is very useful information. Free resource. Anybody can go on there and get that. Coal Authority Consultants Report. Well, if we're doing a desk study, we will write to the Coal Authority and effectively say, what information have you got for us, please? And they will send us a consultant's report back. It tells us what seams they know are present, what seams they know are worked. So this is a site in Bristol, 4 foot seam here. It's at 78 meters depth. The extraction thickness, now that would be the void height. You'd expect that to be the probable void height, 1.2 meters. And it was last worked, I can't read it on this, is it 1849? I think it is. Yeah. And it might tell you what colliery it's worked from as well, which will give you an idea that between that site and that colliery, if you know where it is, there's obviously workings between the two as well. It will tell you any information it has on mine shafts or mine entries in the area. So, for example, there's 2 shafts here. They know nothing about them apart from the fact that there are those grid references. This one, they know it was capped with reinforced concrete, unknown specification in 1962. Okay, so we would expect a concrete cap on that. And then you've got a nice little drawing underneath, nice little map, which shows the purple line is a coal seam cropping across the middle of our site, which is the red rectangle here. And then you can see where the recorded mine entry is. Bear in mind, this is where the Coal Authority have records. They don't have records of everything. I'll come on to that in a second. Now, in fact, we talked about abandonment plans, which were the surveys of the plans of the collieries, the underground workings when they finished. They're very useful sometimes, but they are not the be-all and end-all, as I know some people do think they are. That is actually a survey, and that's probably reasonably accurate in terms of what it shows. However, the first thing is they weren't needed until 1872. So colliery owners didn't bother. So the older workings, we don't have these at all. No, nothing for them. However, they were prepared mainly for taxation purposes. So the exchequer could find out, you dug so many cubic tons of coal out of the ground, therefore we're going to tax you X. Given the nature of the people they were, colliery miners, colliery owners, they were very upstanding pillars of the community. And so they mined their workings completely accurately or not. As Max Boyce, I think, in the song Do It's Hard, was it briefcases full of bank clerks who've never been below? These plans allegedly were checked, but I don't believe they were. I don't think anybody in a suit from London who's a taxman is going to go underground. Bear in mind all I talked about the Acts of Parliament that increased the safety and improved the working conditions. They weren't going to go underground. I have worked on several sites where abandonment plans said the workings are here. For example, I've drilled there and found workings. So take them with a pinch of salt. That's the only thing you can do. And there's other sources, aerial photos, LiDAR surveys. Malcolm Simon's book for Llanelli, absolutely brilliant book for the Llanelli area. Anybody who works in Llanelli, if they're not using that book, they've really got no idea what they're doing. Arabs in 94, I think it was, did a survey of Swansea and Llanelli. And if you remember the earlier slide where I had the different seam names, that was taken from the Arabs report. And there's a gentleman called Ray Lawrence, who I think lives Abergavenny Way, Eastern Valleys anyway. I think he was a former mining surveyor. He's made it his life's work, I think, to write books, little hand self-published books on different collieries across South Wales. If you're working on a colliery and Marine Colliery, for example, is the example I've got here. We did some work on a Marine Colliery. There's stuff in this book that isn't anywhere else. I don't know where he gets the information from. And one example on this, we knew there were two shafts on the site, as you would expect from what I've told you already. But there were stories that there was a third shaft as well, and we didn't know whether that was true or not. Ray Lawrence somewhere found an extract from the Times of London newspaper from 1912 or sometime. And it was actually recorded, opening of the third shaft at Marine Colliery. Really, and the other thing about Ray Lawrence's books, they're not just geology and mining. There's a social history to them. There's a lot. If you're interested in any particular colliery, I've got the one on Coed Ely and Cwm. It's absolutely brilliant. It really is. I can't praise him enough for the work he's done. And finally, Google. Number of times I put a colliery name into Google and come up with something that I wasn't expecting. Very useful. Very critical element of the initial assessment would be a site walkover. You never know what you see. You might see some mine shafts. You might actually see them in the ground, or you might see features like this, ravines where you wouldn't really expect a ravine from looking at the topography. Could it be that there's a mine right at the end there? So why do you do this? Well, the whole point of doing all this is to do a phase one conceptual ground model, get an idea of what we're expecting in the ground. Consider all the information and understand the likelihood of a particular seam being worked. So if you can find out, as we talked earlier, if it's anthracite, is it bituminous? understand whether it's likely to be worked. How thick are the superficial deposits in the area? Be aware of potential unrecorded mine workings and mine shafts, but also beware of red herrings. I'll give you an example of a red herring which somehow has got itself lodged into Coal Authority records and is now, if you don't know better, you think it's an authoritative source. Back in the 1970s, I think it was, there was a surveyor in the Ammanford area who used to get called out on a Sunday morning, phone call, we've got a mine shaft open up in our field. Oh, okay. And he had to go out and have a look at it that Sunday afternoon. And he got fed up of going out there without any information at all. So he went to the office and he decided, a very good idea actually, he'd get a draftsman to put all the information they knew for that area onto one plan so he could roll it up, stick it behind his settee. When he got the phone call, he could pull it out, look at it and say, oh yeah, we have got something there, or no, we haven't got something there. Brilliant idea. It's known as the West Wales Shaft Register, or colloquially as Stan's Plan. Brilliant idea. Poor execution, because he got the draftsman he got to do it was, what words can I use now? I'll use the word rubbish. There are all sorts of mine shafts shown on there which don't exist. There's one in the middle of the Pontardawe River at Pontardawe. And in the olden days, in inverted commas, before you had abandonment plans online, I used to go to the coal office, British Coal offices in Tredoman, Ystrymynach, and they used to bring tables that link this room width to this room, and they used to bring these mine plans out, and you'd look at them all, and there would be ink blots on them marked up as possible mine shafts. But that's an ink blot, yes, but our policy is that we have to mark it as a possible mine shaft. Now the trouble is, wonders of computers. These have all been computerized, and you can't actually see it's an ink blot anymore. You just see as a mark possible mine shaft. So you've really got to be careful because there's a lot of red herrings out there. And Susan will tell you this, my question always to the junior engineers is if you've got a coal seam crossing your site and it's thick enough to be worked and it's anthracite and it's worked somewhere else in the area, why wouldn't they have worked it if it's accessible? And that really has to be the question. So add to this, you come up with a cross section for your site. This is a site in Cross Hands. You've actually seen it before. We'll see it again in a minute. So basically, there's a factory going in here, and they're going to put an extension in there, and it just gives you an idea of what you would expect if you were to drill boreholes. Because the next thing you want to do is then do some investigation. You can do non-intrusive investigations. Familiar with geophysics? I don't know if many of you are. It's basically using the physical properties of the ground. You don't do any damage to the ground at all, but basically what you're trying to find is anomalies. So, for example, on the chart over the plot over on the right-hand side, this area here, well, generally, yes, there are a few little bits, but generally it's pretty consistent. But this big green splodge really stands out, doesn't it? It could be that that's a mine shaft, because it's very different physical properties to the ground around it. There's something different there to everywhere else. Very useful locating mine shafts, mine entries at shallow depth. Once you start to go, the entries are deeper, say they've been covered by 3 or 4 meters of soil, becomes less useful then. And they may not work in certain circumstances. We've got a site in Cross Hands where there's mine shafts beneath the site. They're on Ordnance Survey maps. We know exactly where they are, but you can't use geophysics to prove that because back in the 70s, somebody put a sewer straight across the top of the mine shaft, and that sewer will completely throw the physical properties of the ground, and the geophysics will just see the sewer, it won't see anything else. And geophysics has to be confirmed by intrusive investigation. It's the site in Cross Hands I just mentioned. There you go. So you can see the 2 mine shafts we knew about. They're in here somewhere. Can't see them. A, because somebody's done site clearance and any evidence on the surface will have been stripped away anyway. But as I said, there's 2 mine shafts, there's 2 sewers crossing the site. So how do we go looking for them? Well, if you've got very shallow natural soils, you can do trial trenches and trial pitting. Very good because you can very quickly you can expose a large area to see what you can find. And if you're lucky, you might see something like this, which is a shot of the bell pits we looked at, the Connect 4 bell pits we looked earlier. You can see here that's quite clearly a likely, if you know there's bell pits in the area, that's likely to be a bell pit when you've got the natural soils around a brown and that's black. It's essential that they're deep enough to prove natural ground and not go into fill and make ground on the surface, because you won't see anything in that. You're looking for direct evidence, but also indirect evidence. This is an example of a site near Llanelli, and this is an extract of that site, Malcolm Simon's book I talked to you about earlier. You see the Clingo Wind Pit, it's highlighted in red. We tried to find that mine shaft, we couldn't find it, didn't know where it was. We trenched, there was a lot of made ground in the area, so we had difficulty getting to the natural ground to actually see the shaft. So, and I'm going to take the credit for this because it was my idea. I noticed that the Llangeneth tram road, it doesn't go anywhere else except straight to the mine shaft. So we did some trenching down in this area here, and we found the tram road. We actually found the rail tracks. So we followed those rail tracks, and guess what was at the end of it? A 6 foot by 6 foot mine shaft, which we were then able to deal with. And we dealt with it successfully because Davern Crematorium is built over it now. Trial trench is great to find the mine entries, but when you actually find a mine shaft or whatever, you need to know how deep it is. We know exactly where it is. We can see it on the surface, but how deep it is it filled? Is it filled all the way to the full depth, or is it only filled partway? So we drilled some holes, drilled rotary boreholes to try and find it. These are very dangerous. They could collapse at any moment. So we use a steel grillage, which you can see here. And that basically spans the shaft. The rig sits on it, the drillers sit on it. So if that were to collapse, they're safe. They're stood safely, okay. If we can't see the shaft like that, and we don't know where it is, we might use a drilling pattern like similar to this, where that's where it's shown, maybe on abandonment plans or whatever. We can't find it there, so we then drill in sort of pattern like this, and that eventually, in this instance, you would find it there. Away from mine entries, what about shallow workings? Well, we use exactly the same sort of drilling technique, rotary drilling. Depths and locations of the boreholes will depend on the conceptual model we looked at earlier from our depth study. Generally, we drill to about 30 to 40 metres in South Wales. Absolute minimum of 3 holes, because you need 3 holes to be able to get a dip on the strata. You can't do it from 2. You've got to do it from a minimum of 3. Normally, we use what's known as open hole drilling, where you literally drill, you get chippings back at the surface and you can tell what you're going through. And if you hit voids, the drilling rods just drop. But we can core the bedrock in certain circumstances. And I have done that in a site in Bath above underground stone mine workings in an attempt to understand what the likelihood of subsidence was and collapse. End up with borehole records here. Just a couple quickly, you can see we've got coal seams here, and then there would be a cavity here, for example. And we then improve our conceptual model with a section, and so it's a better model now. It's better. This is the site in Cross Hands we talked about. It's important that you don't just rely on the boreholes as well. You have to keep the depth study information in mind. A previous company working on this joined that seam, and that seam up and said, oh, we've got a sub-horizontal seam here. But the depth study said the strata in the area is dipping at 25 degrees. So the model, we worked at this, and lo and behold, we found workings up here as well. So you've got to be very careful interpreting this information. That's the sort of thing that can happen if a shaft collapses. They're generally very poorly backfilled. Sometimes they're only backfilled at the surface. What they used to do often was they would take an old cold ram, push it up to the shaft, push it into the shaft. At some point on their way down, it would jam off, and then they would fill above it. The other thing they used to do was they put timbers across at the first level, the first set of workings, the shallowest workings, and they'd fill above that. So underneath that dram, underneath those timbers, is a void. That void could be 200 metres deep. Now, at some point, that dram is going to rust, that timber's going to rust, and they're going to give way. And then the whole lot is just going to go boom, and suddenly you end up with a collapse at the surface. And the drilling into fill like this can actually increase the likelihood of that, hence why we use this safety platform we talked about. So away from mine shafts, just a little quick cartoon on how subsidence occurs. So you've got pillar and stall workings here, you've got coal pillars, you've got the voids, coal pillar void. At some point, because oxidation, weathering, water, the roof collapses. So the bit that was there is now lying on a pile on the floor. So the void, as you can see, is effectively migrated up towards the ground surface here. That happens again. The void migrates even further. But and in these two instances, it's unlikely to happen in reality, but just to demonstrate a point. The roof rock that's collapsed here, in this one, is bulked up. It's occupying a bigger volume than it is in this one. The collapse continues. In this instance, it reaches the surface, you get a crown hole feature, subsidence crown hole, the surface. But this one, because it bulked up more, the crown hole is actually choked off. So the void has effectively disappeared at shallow depth. That's never going to reach that surface. You're not going to get subsidence above that. How deep do workings need to be to prevent that happening? Well, quickly, Statham and Trahan in 1991, they did a study of subsidence collapses, and determined that 95% of the incidents occurred where the thickness of bedrock cover was 10 times the workings void height or less. So if your void height is 1 metre, if you've got 10 metres of bedrock above it, statistically, it's unlikely that you're going to get a crown hole at the surface. There's always exceptions. And it's critical that you use the height of workings and not the seam thickness. And what I mean by that, the photograph on the left, it's not very clear, but it's an underground mining photograph. What's the height of that? 1 metre? That's probably the thickness of the seam. That's what most of the workings will be like, men crawling on their hands and knees. If you ever watch the Coal House, the BBC television programme Coal House, set in Blaenavon, was it 10 years ago, 15 years ago? That really demonstrates that quite well. But they needed to get the coal out. So you'd have spine roadways or main roadways on the right. They were nice and high, plenty of room. So you can imagine the void height there and the void height there were completely different. Your 10T calculation for those two would be completely different. Oh, by the way, the one on the right, why was it that high? Was it so that men could walk in and out? No. It was so pit ponies could walk in and out. They didn't care about the men. As long as ponies could get out and get the coal out, that was the most important thing. So how do we mitigate the risk? Well, where you've got shallow mine workings, the easiest way of doing it is actually to move your building if you can. If you've got an area that's high risk and an area that's low risk, move your building to the low risk area. This is the site in Cross Hands where the sewer was put in earlier. What the client did here was he actually changed the development. He did have housing on there, including housing slap bang on top of the two shafts you can see up on the top of the site. He changed it, so it's now another development which occupies the south and east of the site. Still a problem. So what we're doing there is we're putting in a grid of injection holes, rotary injection holes, which are rotary drill holes, but they're left with plastic piping in them. Down to the coal seam, down to the workings. And what we will do, we will pump PFA cement grout into those to stabilise the workings, to fill the workings up, basically. PFA is pulverised fuel ash. It's the waste product at the end of a coal-fired power station, the ash at the bottom. Has been brilliant over my working lifetime because we used to go to Aberthaw and get it. It was fantastic. You know, pretty much every site in South Wales, hour and a half travel time from Aberthaw. Fantastic. Aberthaw stopped working. And now the nearest source of PFA, I believe, is somewhere near Stoke. And if they're not available, it's Warrington. So rather than having, 5, 6 wagons of PFA a day, you might get 2 now. It's getting more expensive to deal with these workings because we have to get the PFA from further away. Can use gravel if you've got open voids to fill the workings. And then when you've done it all, you would do some test bore holes between your injection holes. because you hope to find grout in them, not open workings. And the other thing you do is you reinforce your foundations for any structures above it. Mine shafts, how do you deal with those? Again, the easiest thing, just fence them off. If you're in a remote area, just stop people getting near them. They're fine. They'll be all right. If you've got an open shaft, let's say one we saw earlier, fill it with gravel. And then you do exactly as we do in mine workings, we then grout that with PFA cement grout. If it's near to buildings, near to structures, you would put a reinforced concrete cap, which you can see here. Just sheets of reinforcement, concrete above it, and it would just basically cover the mine shaft. And then again, reinforced foundations nearby. And gas risk mitigation, because mine shafts are a very good conduit for mine gas in the workings to come up to the surface. Drifts and adits, to actually make them safe, you just either brick them up or put a grillage like this, but you have to make sure that if there's any drainage coming through it, that drainage continues. Otherwise, you're just going to get backup of water into the workings, which, as we talked about, the site in Swansea and Dunvant, you can have major problems then. And the ecological impact, you can see up here, you've got a letterbox type structure here. That's to allow bats to get out. And the other thing, obviously, these drifts, they're not just on their own, they lead to workings behind. So don't forget to treat the workings as well. And mine gas. Drilling into mine workings obviously can move the gas around. If you grout up the workings, that gas has got to go somewhere. So it moves somewhere else. Talks about rising groundwater. Rising groundwater filling workings pushes the gas upwards, and gas, methane in particular, will rise to the surface. It can collect under new structures you put in. So you put gas mitigation. Easiest way of doing it. The gas is like water. It's very lazy. It'll take the easiest route out. So you either put a subfloor void in beneath your structure with a gas membrane, which is this yellow sheet. That's completely gas impermeable. Or you do a structure like this, which is a prefabricated voided boxes. Okay. And since 2021, this is new for Kevin, he doesn't know this. Since 2021, you actually have to do a mine gas risk assessment before developments in mining areas. That's it. Thank you very much. Well, thank you.